And we will also observe the differences between distance time and displacement time graph. Okay. So let's have in the last class we had done a position time graph, and in the position time graph we had obtained two results. Like we had seen three types of graphs in that position time graph. So we had done a position time graph in which you will find a line parallel to the time axis. We have also done a position time graph in which we find a straight line inclined to the time axis. And here we find a position time graph which is non-linear. Okay, which does not make a straight line. T-shirt. Okay. So this was the first graph that we had studied. If you have a position time graph, something like this. The second one was we had a position time graph, something like this. And the third one, we had a non-linear graph, maybe something like this. This will be a non-linear graph. Okay. So we have here position time. Here also we have position time. So you can also call it as displacement time graph. Position time and displacement time graph, they are the same. So for this one, for the first one, what can you say about this graph?
So the object is at rest.
Yeah, so the first one, it shows the object at rest. And what will be the value of velocity for the first one?
So 0.
0. So in the
Zero.
first case, here it represents the object at rest,
So
and it
uniform
shows that
velocity.
velocity is 0. And what about the second one? What can you say for the second one?
Sir, it's moving with the uniform motion.
Yeah, it's moving with a constant velocity. In the second graph, it tells us that the object is moving with a constant velocity, and the velocity of the object can be obtained by finding the slope of the curve. So we had obtained here that the slope of the curve, it represents the velocity here in this graph. So in this first graph, we have 0 velocity. Yes.
Sir, we can obtain velocity by finding the slope only when it's moving in constant velocity, no, sir?
Yeah, if it's moving with a constant velocity. If it's not moving with a constant velocity, so then also you can find out, but there are some higher methods. There is some higher mathematics which is involved in finding out the velocity. Okay. Because
Okay,
if
sir.
you try to find out slope here, so you will be getting the average velocity. Okay. And that will not be the actual velocity. You will get the average velocity of it. So here in this one, we obtain velocity as slope of the curve. Slope can be obtained as y2 minus y1 over x2 minus x1. So this is a way we find out the slope, and it is also equal to tan theta. Just another addition, it is equal to the tan theta or tangent of the angle between it. So we also call this slope to be the tan theta. So we say this is our tan theta. Got it?
Yes, sir.
Yes. So tan theta will be equal to the slope, and we can obtain by y2 minus y1 by x2 minus x1. So some of you might not be able to get that what is this tan theta. So tan theta here, tan theta is a trigonometric ratio about which you will be studying in your class 10th. Okay. So currently we just inform that yes, this is your tan theta or the slope, And in the position time graph, if you try to find out the slope, you will get your velocity. So in both of them, you will get the velocity. And to find out that, you can take any 2 points. So here you can take any of the 2 points. Suppose I take this point as, let us take the coordinates of this point to be x2, y2. And let us take here any other point. Let's take this point to be x1, y1. So I can find out the slope. Any 2 points can be chosen on the graph. So to find the slope, we construct a right angle triangle, something like this. So here, this opposite side will be y2 minus y1. So this will be my y2 minus y1. And here the bottom, this will be my x2 minus x1. So this is how we find out the velocity from the position time graph. We will also see that which of the graphs are there. Are all the graphs possible? Can we draw the graph in any shape? Okay. So for this, let's try to see a few more graphs. Let's see if they are possible or not.
So can you explain the y2 minus y1 by x2 minus x1 again?
Okay, sure. So see, to find out the slope, uh, let's check here now. So you want to find out that how the slope is represented by y2 minus y1 over x2 minus x1, right? So let's say, see, we have taken a graph. Here we take the graph of any moving object. So let's say this is the graph and I want to find out the slope. So let's say this is the graph that I have obtained. So you can take any point. Let this be your graph of the object A that's moving. Now on this y-axis, I'm plotting here position. Here I'm taking the position and here I'm taking the time. So it's position and time. Now I take any 2 points to find the slope. I take any 2 points. Suppose I consider this point to be the initial point and this point to be the final point. Since it is at this point after some time, and in the beginning the object is here, so this will be your initial. We call this to be the initial position, which is x1, y1, and this is x2, y2. This is our x2, y2, which is the final position, right? So let me draw the perpendicular from these 2 points. So I draw a perpendicular from this point. Okay, so I draw the perpendicular from here, which cuts the time axis at this point. I also draw a perpendicular from this point on the time axis. So if this point is x1, y1, the distance of this point from here to here should be x1. So this distance should be x1 from here to here, and the complete distance has to be x2. This complete distance has to be x2. Understood this?
Yeah, sir.
In the similar way, I can find out the value of the y component. The y component, we draw a perpendicular from the first point over on the y-axis. If I draw a perpendicular from here on the y-axis, now I draw a perpendicular from this point on the y-axis. So clearly, this will be my y1 and this will be y2. Okay. So this is our y1 and y2. Clearly, the distance from origin to this point will be the y1 distance, and from origin to this point will be the y2 distance. Got this much?
Yeah, sir.
Okay. Now let us see how do we find out the slopes and how it represents the velocity. So for this, now we complete the triangle. So we complete this triangle. And let's mark these points as we already have marked A. Let this be point B and let this be point C. So the slope can be calculated as the method of finding out the slope has to be perpendicular. In this right angle triangle, you find the slope as perpendicular by base. So the length of the perpendicular, that is AC, slope will be given as length of the perpendicular, that is AC, divided by BC. This is the method how we find out the slope of a line. Okay. Now the length of AC is going to be y2 minus y1. Yes. Any problems here? And the length BC is going to be x2 minus x1. Got it? So in this way, I'll be getting the slope as y2 minus y1 by x2 minus x1. Anyone having any problem up to here? How do we find out the slope? Slope
Sir,
actually
what is A?
measures, yeah,
Sir, which point is A?
which point is A. So at the top, we have taken this point as A. This is our A, x2, y2. So the
Okay.
distance AC will be equal to, I can complete this AC like this. So this is our AC. If you find AC by BC, so AC by BC will be perpendicular by base. Got it? So in finding out the slope means how much this line is tilted towards the x-axis. What is the tilt of the line towards the x-axis? If you are getting the tilt as 0, so it is parallel to the time axis. Okay. Now let us try to do this question, clarify it more clearly with some values. Let's have some values given by this. Okay. So here we give some values. Sampath, can you turn on your Sampath, is your camera on? Sampath, Akshara.
Yes, sir. Sir, actually, the light is turned off due to current.
Okay, okay. So see, one common, these are few guidelines. If you are not able to turn on your camera, so just inform through the help and support group. Okay, you have a help and support group over there. Just inform that today I will not be able to turn on my camera. Write your name and I will not be able to turn on my camera. Okay, so that I am well aware of the things that you will not be able to turn on your camera, and whatever class you belong to, you can write mention over there. Okay. Got it? Yes. So that camera and another thing, while if you are not able to, okay, anyway, whatever is the reason, just inform over there in the group so that everyone will be aware. Otherwise, sometimes what happens if anyone's camera is off and you have not informed in the group. So while checking, we find that and then we have to inform in the group. Then we inform that yes, your camera is off and you have to provide that. So it's better you opt it. Okay. Also during the class, if you have to move out or leave out at any time, so just inform a little bit. So I need to go and then you can turn off. Do not vanish just like that. So let's say some values and now try to find out what will be the velocity of this. Okay. So here we have, so let's take some values here. For the time we are taking the values as, let's say here we are taking 1, 2, 3, 4, 5, 6. And let's say here we take 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, so on. So we have taken these points, right? Now, if I want to find out the velocity, So I will take my initial position. So I can take any of the point to be the initial position. So currently, whatever I have marked in this triangle, that is what I am taking my initial position. So for the current situation, I am taking this point B to be the initial position, and I am taking this point A to be the final position, right? So can you tell me what will be the initial position from this graph? Yeah, Harshit, Sampath, Pranav, anyone? Can anyone tell what will be the initial position as represented by the graph? Yes?
Sir,
No
initial.
answers. Okay. See, I have taken this point B to be the initial position. Now, if you draw perpendicular from B on the y-axis, so I obtain the point 20. And on the y-axis, I am plotting the position. Okay. On the x-axis, I am plotting the time. So, can I say that my initial position is 20? Yes?
Yes, sir.
Yeah. See, if you are having any problem or anything, do speak. Even if you do not have, so speak up. Mohammed Rayan, are you able to get the initial position?
Yes, sir.
Okay. So here our initial position is 20, which I have marked with the point y1. So I can write it as initial position. This is y1, which is 20 meter. Let this be position in meter. Mhm. Okay. Now we find the value of y2. Okay. Y2 is the final position. So from this final position A, we have dropped the perpendicular on the y-axis. So what should be the final position? Yes. Can you tell the final position? Rayan, what is the final position?
60.
60. So final position is y2, which is 60. Now, if I know the initial position, if I know the final position, so can I find out the displacement? Say it's something like this. You can assume it to be like this. Suppose this is your road. Let's say you have a straight road, and on the straight road, you have kilometer markings. You have your kilometer markings. So initially when I observed, it was as the marking 20 meter. And when I observed it finally, so it was at the marking 60 meter. So what is the displacement obtained by it?
Sir, 40 meter.
40 meter. Very good. So the displacement is 40 meter. So similarly, that's what we are finding. So our displacement will be 40 meter, which will be equal to the portion AC of the graph. See, this complete portion from bottom to here will be 60. From here to here is 20. So the distance between them, that is equal to AC. This is 40 meter. So I have obtained my displacement as 40 meter. So when I'm finding y2 minus y1, so this y2 minus y1 means displacement. Here I am obtaining displacement. So I have got displacement as 40 meter. And what is the time for this journey? Starting from B to A. What is the time taken? See, when it was at B, the time was 2 seconds. When it is at A, the time is 6 seconds. So what is
4
the time
seconds.
taken? 4
4
Sir,
seconds.
seconds.
4.
So we have time as 4 seconds, and you can find out a velocity as 40 by 4, displacement by time, which is 10 meter per second, right? Now, if I obtain the same thing here, so using this formula of slope, so I get y2 minus y1. That is, I get the slope as 60 minus 20 divided by x2 minus x1. So the value of x2 is 6 and x1 is 2, 6 minus 2. So am I still getting 10 meter per second?
Yeah, sir.
Yeah, I'm still getting the velocity as 10 meter per second. So this is how we find out the slope of any object from the graph. Okay. And if it is a position time graph, so you will be getting the slope as velocity. If it is a distance time graph, then you will get your slope as speed. The slope of the graph would represent the speed and not the velocity.
Sir, can means velocity come in decimals?
Yeah, velocity can be in decimals.
Okay, sir.
Okay.
Sir, how to write tan theta?
Uh, that's the whatever answer you are getting, that is the value of tan theta.
Okay, sir.
Okay. So see here, from any of the graph, that is the formula I have written. Velocity will be equal to the slope of the graph, which will be equal to y2 minus y1 over x2 minus x1. So we obtain here y2 minus y1 over x2 minus x1. That we obtain as the velocity. So this is my position time graph. This is also position time graph. This is also position time. Okay. Now, let's see another position time graph here and find out the velocity. So you have here again a position time graph. Okay. Now, but the graph is something like this. You have your graph like this. Okay. Now you are supposed to find out the velocity. Let's say I'm taking the points here 0, 0 is the starting point. Let this again be 5, 10, 15, 20, 25, 30. Then you get here again 1, 2, 3, 4, 5, 6, 7, 8. Okay. So at the beginning of the time, that means when the time is 1 second, we observe the position of the object. Where is the position of object? Yes, where is the position?
30. 30.
30. So what is the initial position?
30.
30. Akshara? Okay, fine. So I have my initial position here 30. So I'll be taking this point as x1, y1, which is x value is 1 and y value is 30. Now this is my final position. Okay. So the coordinates of this point are
8,
8, 10, right? Now who will tell me the velocity here? Can anyone find out the velocity? And see, you will be getting a negative value. Sampak, are you getting a negative value?
Yes, sir. I'm still doing.
Okay, do it.
Sir, I'm getting as minus 20 by 7.
Okay, so that's correct. You have minus 20 by 7. So are you getting in decimals?
Yes, it's minus 2.85 and it goes on.
Okay. So you have minus 2.85. You will get your velocity or slope that will be as minus 20 by 7, which will be minus of 2.85.
2 point, yes, sir.
Okay. So why you are getting as the negative velocity? Because as per the graph, it shows a decrease in displacement. It is showing a decrease in position. Right? So if you have a graph, yes,
Sir, I'm getting as minus 2.85714 bar.
okay, that's correct. Are you getting minus 20 by 7?
Yeah, sir.
So minus 20 by 7 is 2.8571. Okay. So here we observe that position is decreasing. That means the object is coming more closer. So it has a negative velocity. Got it? Now just for a question, can we have something like this? Okay. Again, suppose we have a position time graph. Not position, we have distance time graph. We have a distance time graph. And now, is it possible for us to have a downward graph, something like this?
No, sir.
Why? Why?
Sir, the graph does not exist in that form.
Why it does not exist in that form? Okay, so as per the graph, if you observe, we have the initial distance is somewhere higher. You have your initial distance which is high and final distance is low. So what we observe from the graph that with increasing time, distance is decreasing, right? So what we have learned so far that with increasing time, distance cannot decrease. Distance can remain constant, but it cannot decrease. Displacement can decrease, position can decrease, but distance cannot decrease. Remember the initial concepts when we were doing about distance and displacement. So we understood over there that distance can never decrease. Once whatever distance you have covered, even if you return back, so distance increases, it never decreases. Okay. So this graph is not possible. This is not possible. Understood everyone that why the graph is not possible?
Yes.
Yeah. So in the similar way, if I draw some graph like this, let's see if you can answer that whether this graph is possible or not. Okay, you have some graph like this. Again, it's, let's say it's distance time or displacement time, whatever it can be. So is this graph possible?
No,
No,
sir.
sir.
No.
Why?
Sir, because
Sir,
he has
because
been
distance can
increased.
increase with time. Time
uh,
means there is constant time and the distance is increasing.
Yeah. So it shows that the object has an infinite velocity. Okay, it shows that it has an infinite velocity. So in just that much of time, it is traveling too much of distance. So it is having an infinite velocity. So again, this is also not possible. Okay. Now let's say some other shapes of the graph which may be possible or may not be possible. So you will try to answer whether they are possible or not. So can you have a graph something like this?
No,
Let's
sir.
say
No.
just one minute. Let's say, okay, can we have a graph like this? Distance and time. Is this graph possible?
No.
Why?
Because the time's increasing and decreasing.
No, see, as if you read out the graph represents that at any instant of time, the object has two distances. For example, at this time, we will find two distance of the object. At this time, we find two distance of the object, right? So it shows that the object has covered two distances in two different time intervals. So that is why this graph is not possible. It's not possible that the same object will be at two positions.
Sir, even in the graph, it's like the time increased suddenly and got decreased.
Yeah. So time can never decrease. Time will go on increasing.
And also the distance is also decreasing.
Yeah. Okay. So I hope now you have understood that which of these can be there. Got it? Anyone having any doubts from this position time graph or distance time graph?
No, sir.
Or you can also have a displacement time graph. So wherever you have studied the position time graph, the same is the condition for if you have a displacement time graph. So position time graph and displacement time graph would be the same. Okay. Now let's have, so shall we start with the velocity time graph now? Or is there, okay, let's do one of the questions from this distance time graph only. Let's do some questions from the distance time graph. So let's see, uh, get some questions here. Okay. So Sampath, Harshit, and Akshara, they are only here. I observe few of them have left the class, right? Just one minute.
Sir, are you presenting?
No, I'm not presenting. Just 1 minute. I'll be presenting just now. Let me take some assignment. I am taking some question from the graph.
Okay, sir.
Just 1 minute. I have. Let me open. Just once.
Sir, are you there?
Yeah, just one second. I'm getting some of the assignment with the graph only. That's what I require with graph. Okay, so okay, so just one more. I've got few questions. See,
Sir, your camera is stuck.
yeah, no, nothing. Just 1 minute. I have the question. Yeah, let's now I can share you. Okay, so you have a question here. You can try doing this. Figure 8.11 shows the distance time graph of three objects A, B, and C. Study the graph and answer the following questions. So I think everything is visible from the graph. If something is not visible, so I mark this. I mark this here. This is your 0.4. This is 0.8. This is 1.2. This is 1.6. Okay. And this you have 4, 8, 12. So this figure shows the distance time graph of three objects A, B, and C. Study the graph and answer the following questions. Which of the three is traveling the fastest?
Sir, B.
Okay. B is traveling the fastest as B has the greater slope. It's making more angle with the
Its slope is greater.
B is greater. B.
Sir, I am also
Same.
telling B.
Are the three are all three ever at the same point on the road? Is there
No,
any point on the road where all of them are at the same position?
no, sir.
No, they are not at the same positions. So there is no. Since all of the three, they are not intersecting at any common point. So the answer is no. How far has C traveled when B passes A? So when B is passing A, at that time, how far A has traveled? So see, B is passing A at this point of time.
Sir, 8
This is,
km.
yeah, 8 kilometers. So at that time, A has traveled 8 kilometers. Then,
Sir, but C is
Sir, C has
right.
traveled 8 kilometers.
Yes, sir.
okay, how far has C traveled when B passes A? Okay, it
Sir,
says
it's
when
Sir,
B,
and
8
also
kilometers.
B is passing
just
a
1 minute, 1 minute, 1 minute. Let me redraw it. When B passes A, C has traveled when B passes A. So you have, yeah, B passing A. This is the point when B passes A.
Yes, sir.
Yeah. So we take this point when B passes A and you drop the perpendicular from here on the time. You find the position of the C. So the position of C is, it's not 8. You'll get here 4, 5, 6,
Sir, can you
7.
please 4.7
No,
or
it's
4?
greater than 9. It's greater than 8. It has to be 9, 10. It's 10 kilometer. Oh, sorry. For C, it's 8 only. Oh, sorry. It's 8. See, it's 8 only. At this instant, it is crossing C at 8. So your answer was correct. It's 8 meters. Got it? In the same way, you have to find for D also. So I hope you can do these questions. Okay. Bye all of you. See you again in next class.
Bye, sir. Thank you, sir.